Again, welcome to lecture 2, statistics. In this lecture, we are going to describe data. So the method we are going to use to describe data is using frequency tables, frequency distribution, and also graphic presentation. So first we start with the frequency table. Example, we can see an example here. I would say the main goal of using frequency table is organizing our data. So for example, if I have 180 cars in these 4 different locations, but the data is not on a table, it means I have to count it. So if it's like a test, a raw test data, telling us the type of car, location car, and all is like a document, we have to count it. But if we organize it using frequency table, we can see that we don't need to count because it's already organized. We have the location name and the number of cars instead of a Word document having it plain. So we have to, again, count in that situation. But we have 2 types of way of using a table. One is the frequency table. We use frequency table if our variable is nominal or qualitative. In this case, we are talking about location. The number of cars will be our frequency, so the total tally. But the main attribute that consists of the number of cars is the attribute name location. So since location is a qualitative data, we cannot find interval between 2 locations. So frequency table, always we should remember our main attribute or variable is nominal or qualitative location. So we can also use the bar chart. For example, most statistics programs comes with the features to, again, visualize our data or create different types of charts. Also, the goal of using a chart is the same as the table. Here, when I create a chart, I can tell each location the number of vehicles we have, we can tell. So again, Kane is 50, of Cran is, Orion is 40. Sheffield, we have somewhere around like 45 or so. So again, the main goal of a chart is to organize our data again. By visually representing our data, we can really understand it very quick. We can see the patterns, etc. Also, we can use a pie chart. A pie chart normally will give us different parts. For example, in this data set, we have vehicle type, the number sold, and the percent sold. But the vehicle type, we have up to 5. So we have to have 5 parts. So here we have truck, compact, SUV, sedan, and hybrid. So each part tells us the percentage of cars sold. So here we're going to use the bar chart and also pie chart for an example. So example they gave us here is that we have a score. And this is the selection. So our song, we have 102, excellent 58, good 30, poor 10. So what we do is that we create a frequency table. Since our variable is qualitative, our sum, excellent, good, and poor. So how many excellent we have? 58. How many good? How many poor? How many our sum? Now that should be our frequency, the quantity, the number of count, the tally. Now relative frequency is like the percentage of the items in each category here, where some is good and poor. So for example, I'll divide 102 by the total of items. I think it's 170. I'm not sure. 190. Well, we can see 102 is 160, 200. So I'll divide 102 by 200, and that will give me the relative frequency of our sum. Divide 58 by 200, it will give me 0.29. Divide 30 by 200, 0.15. Divide 10 by 200, 0.05. So relative frequency is like giving us the percentage or the portion of each category. Our sum. Then again, when you add all the relative frequency value, you should get 1. Or if you are using percentage value, you get 100%. So we can use Excel again to plot a chart, and that will be a different lectures which we will cover. So for example, pie chart using Excel. First of all, we need a data. So using Excel to create a chart, first, you should have a data in the worksheet. Then you select the data. Then you click on Insert. Then when you click on Insert, you select the type of chart you want to insert. In this case, pie chart. So the next is the frequency distribution. Now, what we mentioned before is that the difference between frequency table and frequency distribution is the variable type. We remember frequency table, we are using qualitative or nominal. Here we are using quantitative because we can see here our attributes profit. Profit is a value. So now we can create the crash width. And the crash width have to be the same. So here we say 20 to 600, which is 400 difference. And then 600 to 1,000, same 400. 1,000 to 1,400. So we have to make sure that, again, the crash width is the same. Then we count the number of items fall within each interval. So here, frequency distribution, we should know the crash interval, as we said. And what is a crash interval? A crash interval is obtained by subtracting the lower limit of a class from the upper or from the lower limit of the next class. So here we can see that when we subtract 600 from 200, we get 400. When we subtract 1,000 from 600, we get difference of 400. So we can see 400 is the difference between all the values. 2,200 from 1,000 minus 1,800 still will give you 4. Then the midpoint means we had the beginning value to the end value, then we divide by 2. So 200 plus 600, here 200 plus 600 will give me 800. Then 800 divided by 2 will give me 400. So again, 200 and 600, we find the midpoint to give us average of each lower and upper limit. So 1,000 plus 1,400 will give me 2,400 divided by 2. That will give me 1,200. So that's how we get the midpoint. And as usual, the same as the frequency table, to get the frequency distribution, using the frequency distribution, is the same thing. To get the frequency, we count the number of items fall within each range. Then the class midpoint is a point that divides the class into 2 equal parts. So we have to find the average. This is the average of the upper and lower limit class. Frequency, again, number of observations, so we count it. So this is an example. We have a data set here. And this data set is Kathleen Ball of the Applewood Auto Group wants to describe the data collected on the profit for 180 vehicles sold last month at the 4 Applewood locations. She would like to know what is the typical profit for 180 vehicles sold. Also, what is the largest profit on any sale? What is the lowest profit on any sale? what is the typical value of profit, or around what value of profit does the data tend to cluster. Cluster means combine together. So here, this is our data set, but it's very difficult for us to look this to answer our most important, our three questions. So first, we have to organize this data using frequency distribution. Now, we have to create the class width. There are some textbooks that tell us we should just assume it, maybe use 5, 6, look at the number of records you have, etc., to come up with the class width. But sometimes also there's a techniques that we can use. So step one, we should decide on the number of classes we want. In order to do this, assumption we can say 5 to 7 or any amount, we will still get the answer. But the useful recipe to determine the number of classes k is to raise 2 to the power k. If 2 to the power k is greater than n, lowercase n, which means the sample size. So, for example, we have 180 cars sold. So that's our n will give us 180. So we try to put 7 as k. The goal is that this condition have to be met. So if I put 3, 2 to the power 3 is 8. So is 8 greater than 180, greater than n? No. So 3 is not good. So we try 7. 7 gives us 128, which is less than 180. But here 7 is not enough class, so we move on to 8. Again, condition said it should be greater. The least value that is greater than n. So we use 2 to the power 8. 2 to the power 8 gives us 256. Remember, our n is 180. So yeah, 256 is greater than 180 n. So we take 256, which is 8. So now we know the number of classes is 8. Next step is to determine the class interval or the width. So the formula to do that will be the look at the highest and the lowest value, subtract the highest and the lowest, then divide by the number of k, which we just calculated in step 1. So now this will give us 374.75, because the highest minus the lowest, the highest is 3292, the lowest is 294. So we find the difference of the two, then we divide by the k, and the k in this sense is 8, which we found in the first step. Now, when you have 374, it's very special decimal value is difficult, because this value will be the interval, the class width. So we can approximate it to 375 or 374. Remember, we have 8 classes. So you can see the class here, 1, 2, 3, 4, 5, 6, 7, 8. And based on the values that we have, and also the class width is 375, we make it 400. So we move from 200 to 600, 6 to 1,000, and then 1,000 to 1,400. So this is how we set our class width. And the first step again is to decide the number of classes you are going to have. And the rule to do that is 2k should be greater than n, and k will be the number of classes. So if your sample size is 180 in this case, the correct answer will be 2 to the power 7 will give me 128, which is lower. Then 2 to the power 8, that's good. That will give me 256, so that's good. 256 is better, so that's why we say the number of classes is 8. Now we need the interval of each class. The interval is the same for all the classes, but there's a formula for this, which is the highest value minus the lower value divided by. So the highest value minus the lower value divided by k. So, and 374, we can approximate it to 400, or 375 or 380. Here, because we are using 2 zeros, we decided to approximate it to 400. And you can see that we get our 8 classes. And the difference of each is 400. So here they say we should tally the vehicle profit into the classes. Then also we should count the number of items in each class. So relative class frequency, as we said earlier, relative is like a part or percentage of each category. So if I have 52 for cane, 52 divided by 180, which should give me 0.289. So again, the relative frequency will capture the relationship between the class total and also the total number of observations. So this is our overall frequency distribution. We have the profits. How do we get the class? We use the condition 2 to the power k greater than n and assume k equal to 1, 2, 3 until the value there should be greater than the sample size. How do we get the frequency? We just go to the data set and count how many values are in each interval. Then how do we get relative frequency? We get relative frequency is like a percentage or proportion. So we divide each category by the total, and that will give us relative frequency for each. Now, when you add all the relative frequency, you should get 1. So this is what we write. We find by the first frequency is 8 divided by the total, 11 divided by the total, 23 divided by the total. And that gives us the relative frequency values. So again, one more time with this table, the first thing to get a frequency distribution is to know your class and also your class interval. Yeah, our class is profit. Our interval is 400, but how do we come about it? First, we have to know the number of classes. So we say 2K should be greater than N, which is the sample size. So start with the value K equal to 1, 2, 3, all the way until the condition will be met that 2K should be greater than N. N is the sample size. N is the sample size. So we're able to come up with this. And then next is the class interval. So the class interval means take the highest value minus the lowest value in the data. In the whole, again, the data set, then you divide by the number of K. So highest value minus minimum value divided by K. K is the number of classes. So that's how we come up with this. So to find the frequency, we just have to find the total tally in each category. To find the relative frequency, to find the relative frequency, we divide, actually, as we said, it's right here. So divide 8 by 180, 11 by 180, 23 by 180, etc. So we can displace of frequency distribution. The most three commonly used graphic forms are histogram. So we can see histogram, the number of classes, the classes is the x-axis. So we can see 15, 18, 21. So that's the histogram classes. Then the bar tells us the frequency. And the same thing applies to frequency polygon. We have the number of classes, the number of vehicle again. So histogram, we said it's a graph in which the classes are marked on the horizontal axis and the class frequency on the vertical, as we said earlier. So the x-axis is the class and the frequency is our y-axis. We can use Excel. Again, Excel, all the graphs, the steps are have your data in the worksheet, select your data. If you create a graph without a data, you get an empty graph because again, the bars we are seeing here, the graph we are seeing here, it represents the number of data. So for example, I'll take the first, which is 600 interval, the given somewhere. But the correct accurate answer is from the table is 8. So again, this is the histogram using Excel. Enter your data into the worksheet, select your data, click on Insert menu, then look for histogram. Go to the chart group area, then look for the histogram. This is a cumulative frequency distribution. The word cumulative means we are adding the previous values. So kind of like a relative frequency concept, but relative frequency is different in the sense that we are looking for a part or a percentage of each. But cumulative frequency basically means we are adding the previous. So what I'm trying to say is we have a cumulative frequency of 8. Okay, so that's correct. Now the next is 19. Why is it 19? Because the previous is 8 and at present is 11. Then why is it 42? Okay, it's 8 plus 11. By this time we have 23. So these are the values 8, 11, 23, 28. These are the values that represent the frequency for each. So we had the previous frequency to the current one to get the current cumulative frequency. So because the data will be increasing, this is the shape of a cumulative frequency distribution. And when you reach 100, it cannot go further. So again, thank you for this lecture. And in this lecture, I'll cover the concept of describing data. What is frequency table? What is frequency distribution? And next lecture, we are going to talk about stem plot, dot plot, etc. So again, thank you.